All right, so the table method won't work for this example. This is because this is not a polynomial and that is not a polynomial. Right, so the table method only works when we have a polynomial piece that we can make into u. Right, so let me show you how to do this one. You need to know how to do this for the written homework. I guess that'll be written homework 3. All right, so what you want to do, so I'll just start first, I'll rewrite this thing. We got cosine x dx. So first let's say we set u equals e to the x dv cosine x dx. So du is e to the x dx, and v equals sine x. Now you can check just by taking a derivative. The derivative of sine is cosine. Okay, so we know we did that right. All right, so this is uv, that's e to the x sine x minus integral of v du. So we have sine x e to the x dx. Now I'm going to rewrite this as e to the x sine x. But there's no reason necessarily to actually have to do that. Okay, so then we get there. Now I'll do integration by parts again with this integral here. So this time we'll say, again, u is e to the x dv is sine x dx. So du is e to the x dx, and v is negative cosine x. Again, you can check your work there. Derivative of cosine is negative sine, so the negatives cancel and we get back to that there. All right, so this is uv, so that's negative e to the x cosine x, right? That's u is e to the x, v is negative cosine, that's why we get that negative there, minus the integral of v du. So we've got negative cosine x times e to the x dx. And the thing to notice at this point is that, see that integral there? That's exactly what that integral is there. So we went in a big circle. Oh, that's right. I had that line in there to separate things. Okay. All right, so we have e to the x sine x and now we have minus minus there, minus minus, so those minuses will become a plus. Remember, you can pop that minus out, so this becomes plus, and now I'll rearrange it, e to the x cosine x dx. And now distributing that negative through, you see what happens here. That becomes positive, and that becomes negative. All right, all right. Go away, please. All right, and so that's, so like I said before, right, you see that is exactly that right there. All right, so let me give myself some room now. And show you how we deal with this. This is equal to e to the x sine x plus e to the x cosine x minus the integral e to the x cosine x dx. All right, and again, notice that these are the same thing here. All right, so before I actually do this operation I'm going to do now, which is really just adding this to both sides, I have found that a lot of students have a better time of seeing what's going on if I do a little example first. Okay, so let's say this is b plus c minus a. So if you wanted to solve for a in this case, and this is a completely different example, okay, I just want to show you that if you add a to both sides, those go away, and you get something like 2a equals b plus c, right? Okay, so we're going to do exactly the same thing here. We're going to add e to the x cosine x dx to both sides. That's going to cancel over there. And we'll get two of these things. 2 times e to the x cosine x and now to solve for this thing, we divide by 2 or multiply by a half. So that turns into putting a little 1/2 in front there, plus c. And so that's the answer.